Hi, in this video we look at the inverse of a function. So we've already looked at a function as kind of this machine that maps of an input value from the domain to an output value in the range. So if we normally have inputs x and outputs y. So let's suppose that f is a function that maps x to y. Well, its inverse, which we denote as f superscript minus 1, would just map y to x. So it maps the range back to the domain. And I've kind of drawn out an example of this. So let's suppose that f has domain 1, 4, 5, and 7. And 1 maps to 7, 4 maps to 2, 5 maps to 9, and 7 maps to 15. So this is the domain, and this is the range. Well, the inverse of the function f, which we denote as f superscript minus 1, would map 2 to 4, 7 back to 1, 9 back to 5, and 15 back to 7. So its input is now the range of f, and its output is the domain of f. So you can see that f inverse basically undoes what f does. An important thing to note, this is kind of something that's a little bit sloppy about inverses of functions, but we use a superscript here. And normally a superscript, superscript minus 1, normally if you were to write x to the power of minus 1 or x superscript minus 1 in math, that would mean 1 over x. But a really important thing to note is that f inverse of x is not equal to 1 over f of x. That is definitely not true, okay? So that's something that's really important to keep in mind. Even though x to the power of minus 1 is equal to 1 over x, f inverse of x is not equal to 1 over f of x. So the best way to kind of get used to dealing with inverses of functions is just to go through and actually find a bunch of inverses of functions. So here I've got a problem. It says, problem 1, given f of x is equal to minus 2x plus 6, determine the inverse of f. And then here it says, is the inverse a function? So in some cases, the inverse isn't always a function. We're going to see why. So given f of x is equal to minus 2x plus 6, how do we find the inverse? Well, if we go back to our definition of what an inverse actually is, if a function f maps y to x, then its inverse maps if a function maps x to y, then its inverse maps y to x. So what we can do is we can swap x and y in our function, and then we can just solve for y in terms of the new x value. So you'll see why this works in a second, but what we can do is we can say, okay, normally our function is f of x is equal to, or we have y is equal to f of x, which is equal to minus 2x plus 6. Well, here we're just going to swap x and y. So we've got that x is equal to f of y, which is equal to minus 2y plus 6. And now we're going to solve for y in terms of x. So we've got an equation here. We've got x is equal to minus 2y plus 6, and we'll solve for y in terms of x. So if we do that, we get we can subtract 6 from both sides, and I get that minus 2y is equal to x minus 6. I can divide both sides of this equation by minus 2, and I get that y is equal to negative 1/2 x plus 3. So next it wants us to sketch the graphs of f of x and its inverse. So f of x is just a straight line, and this is the inverse. And we can write the inverse as, we'll denote it as f inverse of x. And here I've used function notation because y is equal to minus 1/2 x plus 3 is a straight line. So this, because it's a linear graph, it'll pass the vertical line test, and thus it is a function. So I can use function notation for the inverse, and I can write it as f inverse of x, which is equal to minus 1/2 x plus 3. So this is the function the inverse function that I'm going to graph. But first I'll graph the function f of x. So let's go ahead and we'll plot the y-intercept, which is positive 6. We'll follow the slope. So we're going to go over 1 down 2, over 1 down 2 because the slope is negative 2, over 1 down 2. And then I can go ahead and I can graph a straight line through all these points. Okay. So this is the function f of x. Next, let's graph the function, the inverse function, which is minus 1/2 x plus 3. So first we'll graph the y-intercept, which is positive 3. And then we'll follow the slope, which is negative 1/2. So that means we're going to go down 1 over 2, down 1 over 2, down 1 over 2, and we can trace that pattern backward as well. So we know that all of these points are on our inverse function. The last thing that we'll do is we'll just go ahead and connect all of these points using a ruler or a straight line feature if you're using a software program. And we'll label it as the inverse function, or the inverse of f. And since the graph passes a vertical line test, the inverse is a function, so I can use function notation. Another thing to identify is that here it says, how are the graphs related? So how are these two graphs related? So this question's a little bit tricky, but suppose that we graph the line y is equal to x. You might have noticed something here. If we graph the line y is equal to x, this is also called the identity line. You might have noticed that, so that's the graph of y is equal to x. You might have noticed that the two graphs are a reflection about the identity line, about the graph y is equal to x. And that's something that's a property that all inverses have, is if I have the graph of f of x, and if I have the graph of f of x, and I want to get the graph of its inverse, I can just reflect it about the line y is equal to x. Another important thing to note is, remember what we said. We said here that if I have a point if I have a point 1 comma, like here I had a point 1 comma 7 on the graph, or on the graph of f, then 7 comma 1 is on the graph of f inverse. Okay, so the x and the y values actually swap here. So if you have the graph of f of x and you want to graph its inverse, you can just swap all the x and y values of the individual coordinates, and that'll give you the graph of the inverse. So here it says, how are the graphs related? So first thing to note is that they are reflections of each other. About the identity line. The identity line. Another thing to note is that the points on f inverse of x here are just the are the let's say let me rephrase that. The points on f inverse of x are the points of f of x with the x and y values swapped. Okay, so we're going to explore this this concept further in the next video.